Okay, so today we're diving into some seriously influential stuff, the Vienna Circle.
Ooh.
And I gotta say, I'm pretty pumped for this one.
Yeah, me too.
It's like, those philosophical movements that just kind of like shake up how you think about the world.
Right.
This is one of those.
Totally. Yeah.
So basically, we're going to be like time travelers,
Mm.
heading back to the early 20th century,
Okay.
hanging out with these radical thinkers who are trying to like
Mhm.
reimagine what knowledge even is,
Yeah.
all with the help of some shiny new tools from physics and formal logic.
Exactly. They saw all the wild stuff happening in science,
Mhm.
and they were like, okay, we need to update our philosophy to match.
Yeah, like Einstein's theory of relativity just blew everything wide open.
Totally.
And these guys were like, all right, empiricism 2.0, here we come.
Right. Like, how do we make sense of knowledge now
Right.
with all this new stuff we're learning about the universe?
Exactly. So for you, dear listener,
Yeah.
buckle up. We're going to unpack like the core ideas of this group, why they're still relevant today,
Mm-hmm.
and like how they grappled with some seriously big questions.
Yeah.
Like what makes a statement meaningful?
Yeah.
How does science build knowledge?
Yeah.
That kind of stuff.
Huge questions.
Huge questions.
Okay.
Right. And our trusty guide for this journey is the Stanford Encyclopedia of Philosophy.
Classic.
A classic.
Always reliable.
Super comprehensive.
Yeah.
So, we're in good hands.
Mm.
Now, I know philosophy can sometimes feel like a bit of a jungle, right?
Mm.
Like all these dense ideas and jargon.
Right. Right.
But don't worry, we're here to be your like intrepid explorers.
Uh-huh.
We'll hack through the underbrush,
Hmm.
point out the most fascinating philosophical flora and fauna,
Cool.
and give you a clear view of the landscape.
Sounds good.
All right, so let's jump right in. What was the central driving force behind the Vienna Circle? What were they all about?
Well, at their heart, they were all about updating empiricism for a new era. They were like, hey, experience is still the main source of knowledge, but we got to refine how we think about it. And a big part of that was their hardcore anti-metaphysics stance.
Anti-metaphysics.
Yeah.
So they were basically like down with science,
Mm.
but suspicious of any big abstract claims about reality.
Yeah. Stuff that you couldn't test in a lab or prove with logic.
Right, like, is there a God?
Right.
What's the meaning of life?
Yeah, those kind of questions.
Exactly.
They were like, oh, not so fast.
Not so fast.
Let's stick to what we can actually observe and verify.
Okay, so it wasn't just like a personal preference, this anti-metaphysics thing.
No, it was core to their whole philosophy. They called it the empiricist criterion of meaningfulness.
The empiricist criterion of meaningfulness.
Yeah, basically their rule for deciding what statements are actually worth talking about.
Okay, so like a filter for BS.
Uh-huh. Kind of, yeah.
Okay, I'm intrigued. Tell me more.
So they said for a statement to be meaningful, to actually tell us something about the world, it has to meet one of two conditions.
Two conditions, okay?
Lay it on me.
One, it's analytic.
Analytic.
Meaning
Okay.
true by definition or by logic. Like all bachelors are unmarried.
Okay, classic example. Those
Yeah.
are tautologies.
Exactly. Or
Yeah.
two,
Mm-hmm.
it's empirically verifiable.
Empirically verifiable, so like you can test it against observations in the real
Well,
world.
exactly. You got to be able to check it somehow.
Yeah.
If you can't, even in theory,
Then what?
then they considered it meaningless.
Meaningless. Whoa, that's a bold move.
Yeah, they didn't mince words.
So basically, if a statement couldn't be linked back to what we can observe
Mm.
or to pure logic,
Yeah.
they were like, nope, not playing that game.
Haha, exactly. They were like, that's just a bunch of hot air.
So what happened to like all the traditional philosophy, all the big questions about existence and morality and all that?
Well, they saw a lot of it as
Mm.
bogged down in these pseudo-problems.
Pseudo problem. Yeah, questions that arise from like misunderstandings of language.
Okay.
Or that just don't have any real answers
Mm.
because they're not based on anything we can actually investigate.
So they were like decluttering the philosophical landscape.
Yeah, that's a good way to put it.
Okay, so where does math fit into all this?
Oh, math was huge for them.
Huge.
They were all about this logicist conception of math, meaning they believed all those mathematical truths. They ultimately boiled down to logical truths.
Interesting. And why was that so important to them?
Well, it let them hold on to empiricism while still accounting for like the rock solid certainty of math.
Okay, so they were like, math is awesome,
Mm-hmm.
but it's not some mystical separate realm of knowledge.
Right. It all comes back to logic,
Mm.
which they saw as connected to the way language and the world work.
Okay, now there's this other big philosophical idea they went after, synthetic a priori knowledge.
Ah, yes, Kant's big contribution.
Right. Kant was like, there are these truths that are both independent of experience and tell us something new about the world.
Yeah, like built into our minds somehow.
Right, like the idea that every event has a cause.
Right.
The Vienna Circle was like, nope, not buying it.
Not at all. They said science itself had disproven this. Think about non-Euclidean geometry
Okay.
and how it got used in Einstein's theory of relativity. That showed even something as seemingly fundamental as Euclidean geometry, everyone thought was like a prime example of synthetic a priori knowledge. Could turn out to be false.
False, yeah, as a description of the physical world.
Right. So the Vienna Circle was like, if even geometry can be revised based on experience, then this whole idea of synthetic a priori knowledge is out the window.
Out the window. That's a pretty big philosophical slam dunk.
Yeah, they were not afraid to take on the big names.
Okay, so it wasn't just about like categorizing statements as meaningful or meaningless.
No.
They had a bigger game plan.
Right. Definitely they wanted to like dissect scientific theories and see what made them tick.
Okay.
They wanted to put those theories into a super rigorous logical framework and show how they actually worked.
So like expose the machinery under the hood.
Yeah, exactly. And they wanted to highlight the role of conventions.
Conventions.
Yeah, things like definitions, analytical principles, the stuff that gives scientific theories their coherence.
So they were like, science is awesome, but let's be really clear about what makes it work.
Right, and how those choices we make about how to define things, how to structure our theories, they actually shape our understanding of the world.
Okay, so they were like, science isn't just about like pure observation. There's this whole layer of like logical scaffolding that we build.
Yeah, and being aware of that scaffolding is crucial.
That's fascinating. And is that like, is that what led to analytic philosophy of science?
It's definitely a big part of the story. You know, that kind of second order reflection on science?
Right.
Thinking about how science thinks?
Yeah, exactly. All right, so we've got like the blueprint of the Vienna Circle's project. Now, who were the main players?
Oh man, there were some serious heavy hitters in this group.
Okay, give me the all-star lineup.
Well, first up, you gotta have Moritz Schlick. He was like the OG.
Okay, the original gangster.
Yeah, he kind of led the charge in the early days.
Yeah.
Then there's Rudolf Carnap.
Rudolf Carnap.
Dude was a philosophical rock star.
Okay.
His work is still super influential today. Otto Neurath was another big name.
Okay.
He was all about the social and political implications of their ideas.
Interesting.
Yeah, they weren't just armchair philosophers. They wanted to change the world. Okay, then we got Hans Hahn, a mathematician. Carl Menger, another math whiz.
Okay.
Philip Frank, a physicist.
Okay, so a multidisciplinary crew.
Oh, yeah. They brought all kinds of expertise to the table. Friedrich Weissman was another key figure. Okay.
He was tight with Wittgenstein.
The enigmatic Wittgenstein.
Right. And last but not least, Herbert Fiegel.
Herbert Fiegel. All right, so this is like a real philosophical dream team.
Yeah, they were the Avengers of early 20th century thought.
Haha. But I imagine they didn't always agree on everything, right?
Oh, heck no.
Okay, good. Because, like, if everyone's just nodding along, that's not a very interesting conversation.
Right. These are brilliant, independent minds. They were bound to clash sometimes.
Okay, so spill the tea. What were some of the big disagreements within the Vienna Circle?
Well, like, even early on, Schlick and Carnap, their work before they were fully in the circle.
Okay.
It shows a broader range of influences than what we usually associate with logical positivism.
Okay.
They were reading all sorts of stuff, not just the usual suspects.
Interesting.
And later on in the 1930s, you see some real shifts and contradictions between what you might call the orthodox view.
And what different members were publishing?
So the orthodox view was itself kind of a moving target.
Yeah, definitely. It was constantly being negotiated and redefined.
Okay. Give me an example.
Well, Schlick himself, he actually criticized the Vienna Circle's own manifesto.
Their own manifesto?
Yeah, the one they published in 1929.
Whoa. Okay, so they weren't afraid to, like, critique their own work.
Nope. They were all about self-reflection and revision. And then there's Weissman's planned book on Wittgenstein.
Okay.
Which Schlick was a big supporter of. It never got finished the way they planned.
Okay.
But the transcripts from the Circle's discussions, they suggest that Weissman's Wittgensteinian theses from around 1930. They were pretty close to the dominant view at the time.
The dominant view, okay.
But even that wasn't universally accepted.
Interesting.
So yeah, there was always debate.
Always debate. Okay, so it wasn't like a group of disciples just like spouting the same dogma.
Yeah. No, it was a much more dynamic and messy process. A real intellectual conversation.
Okay, I like that image. Much more like a lively seminar than a cult.
Yeah, exactly.
All right, let's dig into one of their most famous and controversial ideas.
Yeah.
The criterion of meaningfulness.
Ah, yes, the big one.
How did they actually see this working in practice?
So as we talked about earlier, they said synthetic statements, those that give us near info about the world,
Right.
they're only meaningful if they're empirically testable.
Empirically testable. Okay, so you got to be able to check them somehow.
Yeah, at least in principle.
And what if you can't?
Then they're meaningless.
Meaningless, like they don't even have a truth value.
Right. They might have other kinds of value.
Okay.
Emotional, poetic, but not cognitive value.
Yeah, okay, so this is where their whole anti-metaphysics stance comes in.
Exactly.
Because metaphysical claims are, by definition, untestable.
Right. You can't go out and measure the soul or do an experiment to prove the existence of the absolute.
So they were like, bye-bye metaphysics.
Pretty much, yeah.
And they also rejected this third realm of significance, right, beyond analytic and synthetic statements.
Right. That was a direct challenge to Kant and his idea of synthetic a priori knowledge.
Right, which they thought science had disproven.
Exactly. They were like, look, if even geometry can be revised based on new observations, then this whole idea of innate knowledge is shaky.
Shaky. Okay, so this criterion of meaningfulness was like their weapon of choice.
Yeah, it helped them redraw the map of what they considered legitimate philosophy.
But it sounds like even within the Vienna Circle, there were different views on what philosophy should be.
Oh, definitely.
Once they got rid of all the metaphysics.
Right, like what's left for philosophers to do.
Exactly. So what were some of those different conceptions?
Okay, so you got Schlick. He thought philosophy still had a distinct role.
Okay.
Separate from the sciences. He saw it as all about clarifying meaning.
Clarifying meaning.
Yeah, like really digging into the concepts we use.
Right.
Both in science and everyday life.
So like conceptual analysis.
Exactly, a kind of rigorous cleaning up of our language.
Okay, and what about Carnap?
Carnap was more into the formal stuff.
Formal stuff.
Yeah, he thought philosophy should be the logic of science.
The logic of science. So like figuring out the rules of the game.
Yeah, basically he was all about building these precise logical systems and showing how scientific theories could be expressed within them.
So for Carnap, philosophy was like a kind of logical engineering.
That's a great way to put it.
Okay, and then there's Neurath.
Ah, Neurath the radical.
Okay, what did he think?
Well, he was basically like, let's just get rid of philosophy as a separate discipline.
Whoa, okay, bold move.
Yeah, he was all about unified science.
Unified science. So like merging philosophy and science into one big project.
Yeah, he thought what was left of philosophy, after chucking out all the metaphysics, was basically just a part of science.
Okay.
A meta-theory that studies science itself.
So like science studying science.
Exactly. And he was super into the practical applications of this.
So like actually using this unified science to solve real-world problems.
Yeah, he was a pragmatist through and through.
Okay, so within this one group, you've got like 3 totally different visions of what philosophy should be.
Right. It just shows how dynamic they were.
Super dynamic. Okay, now it's easy to think of all this as like abstract intellectual stuff.
Yeah.
But our source says the Vienna Circle's ideas were actually socially and politically explosive.
Oh, yeah, they definitely ruffled some feathers.
Okay, why was that?
Well, I mean, just think about it. They were going around declaring their opponent's statements meaningless.
Meaningless.
Yeah, not just false, but like not even worthy of consideration.
Ouch, that's gotta sting.
It's like saying you're not even playing the same game.
Right.
Your ideas are so far out there. They don't even make sense.
Okay, so it was a very powerful rhetorical strategy.
Yeah, they weren't messing around.
And it shows how much they cared about, like, clear thinking and evidence-based reasoning.
Right. They saw those as essential for a healthy society.
So they weren't just, like, ivory tower philosophers detached from the real world.
No way they were engaged with the issues of their time. Especially the rise of fascism and all that.
Yeah, that was a dark time in history.
Right, and they saw the dangers of these like irrational ideologies that were gaining traction.
Okay, so their philosophy was like a direct response to the political climate.
definitely they felt a responsibility to speak out.
Against what they saw as dangerous nonsense.
Exactly.
All right, so despite their big ambitions, their project did run into some snags, right?
Yeah. My philosophical movement is perfect.
Right, so what were some of the main criticisms and challenges they faced?
One of the big ones was they couldn't quite nail down that demarcation criterion.
The demarcation criterion.
Yeah, the rule for separating meaningful scientific statements from meaningless metaphysical ones.
Right, they wanted like a clear-cut test.
Exactly.
But it proved elusive.
Yeah, they kept running into problems.
Okay, like what kind of problems?
Well, one big issue was reductionism.
Reductionist.
Yeah, the idea of reducing all knowledge to some basic foundation.
Okay.
Like sense data or physical facts.
And why was that a problem?
Well, it turned out to be way harder than they thought.
Okay.
Like, how do you reduce complex scientific concepts to just pure observation?
Like electron or gravity.
Exactly. Those terms seem to have meaning that goes beyond just what we can directly observe.
Right. They're theoretical constructs.
Yeah, and that caused real headaches for the Vienna Circle.
Okay, so reductionism hit a snag.
Yeah, it wasn't the clean sweep they were hoping for.
And what about their attempts to define meaning using just logic?
That also ran into trouble. Okay. Natural language is just so messy and complex. It's hard to capture all its nuances with formal logic.
So their formalist approach had its limits.
Yeah, it couldn't quite handle the richness of human language.
Okay, so that leads us to another big idea.
Yeah?
The analytic-synthetic distinction.
Ah, yes. A cornerstone of their thought.
Right. They put a lot of weight on that distinction.
They did. It was central to their whole program.
Okay. Remind us what that distinction is all about.
So they said all meaningful statements can be divided into two types.
Two types, okay.
Analytic statements, which are true by definition or logic.
Okay.
Like all bachelors are unmarried.
Right. We talked about that one.
And synthetic statements, which are true based on facts about the world.
Okay. So analytic truths are like true just by virtue of how language works.
Yeah, and synthetic truths depend on how the world actually is.
Right. Okay.
Well,
and how did this distinction help them fight metaphysics?
Well, they argued that metaphysical statements, they're neither analytic nor synthetic.
Okay, so they fall outside their whole system of meaning.
Exactly. They're like imposters trying to sneak into the realm of knowledge.
And they also used this distinction to support their logicist view of math.
Right. They said mathematical truths are actually analytic, true by virtue of the rules of logic.
But this distinction itself came under fire. Right?
Oh, yeah. It got hit pretty hard.
By who?
Well, most famously by W.V.O. Quine.
Quine, the philosophical giant.
Yeah, in his essay, Two Dogmas of Empiricism.
Okay, and what did Quine say?
Well, he basically challenged the whole idea that you can draw a sharp line between analytic and synthetic truths.
So he was like, it's all a bit blurry.
Yeah, he argued that all our knowledge claims are revisable based on new evidence and experience. So there's no like fixed boundary between truths of meaning and truths of fact.
Okay, that's a pretty radical challenge.
Yeah, it shook the foundations of logical positivism.
And how did the Vienna Circle respond to this?
Well, Carnap in particular, he tried to defend the analytic-synthetic distinction, but within a more formal framework. He said, yeah, maybe it's fuzzy in natural language, but within a formal system, we can define analytic truths as those that follow from the rules and definitions of that system.
So like a kind of internal coherence within a specific system.
Exactly.
But even that got complicated, right?
Yeah, when Carnap started talking about semantic rules and these things called meaning postulates.
Meaning postulates.
Yeah, it's basically like extra definitions that expand the range of analytic truths. Quine was like, hold on, aren't you just smuggling in meaning from the back door?
Like it's circular reasoning?
Yeah, he thought Carnap was presupposing the very thing he was trying to define.
Okay, so it was a deep philosophical disagreement.
Yeah, they had different conceptions of what meaning even is.
Right.
Carnap was more open to intentional notions, while Quine was a hardcore extensionalist.
So like different views on the relationship between language and the world?
Exactly.
And what about that issue of defining logical truth?
Oh yeah, that was another sticking point. Saunders MacLean, a logician, he criticized Carnap for not giving a good formal definition of logical terms.
Ouch, that's a pretty fundamental problem.
Yeah, but later on, Carnap's buddy, John Kameny, He came up with a model theoretic definition of logical truth,
Okay.
which Carnap ended up accepting.
So they managed to patch that hole.
Kind of, yeah.
But the broader debate about analyticity continued.
It did.
Okay, so for Carnap, the analytic-synthetic distinction was more like a useful tool than a fundamental truth about reality.
Yeah, he saw it as a way to make our theories more systematic and clear, not as a reflection of some pre-existing division in the world.
Okay, now another big thing people associate with the Vienna Circle is reductionism and foundationalism.
The quest for the ultimate bedrock of knowledge.
Right, like reducing everything to sense data or physical facts?
Yeah.
Is that an accurate picture of their project?
Well, it's complicated.
Hi.
Our source argues that calling them all foundationalists is a big misunderstanding.
Okay, so there was more nuance there.
Definitely.
Okay, so let's break it down.
Okay.
First, we got phenomenalist reductionism.
Yeah, that's the one where you try to reduce everything to sense data,
Okay.
like your raw experiences of the world.
And then there's physicalist reductionism.
Right, that one's all about reducing everything to physical stuff.
Okay, and the Vienna Circle dabbles in both.
Yeah, they explored both approaches,
Okay.
but it wasn't always about finding an absolutely certain foundation. Sometimes it was more about showing how concepts are connected
Okay.
or how we can achieve objectivity and agreement.
So like a different kind of motivation.
Right.
Okay, now what about Carnap's famous book, The Off-Bow?
The off-bow.
That's often seen as a classic example of phenomenalist reductionism. It is, yeah.
But our source says, even there, Carnap was already hinting at a physicalist approach.
He was.
Okay. And they argue that the main goal of the off-bow wasn't really foundationalism.
Right. It was more about showing the structure of our concepts and how we can build a shared understanding of the world.
Okay, so like a different kind of project.
Yeah.
And what about Quine's criticism of the off-bow?
Oh, yeah. Quine was like, you haven't really defined this key relation is at.
Is that okay?
Which you need to ground your phenomenal objects in space and time.
So he poked a hole in Carnap's system.
Yeah, he pointed out a weakness.
Okay, now what about the move towards a physicalist language? Was that also about finding a more solid foundation?
Not necessarily.
Okay.
Like guys like Neurath and the later Carnap, they weren't really after ultimate certainty. They were more interested in finding a language that could capture the complexities of science.
Okay.
And that could be used for practical applications. So a more pragmatic approach.
Exactly.
Okay, and Neurath was especially anti-foundationalist, right?
Whoa, yeah, he was like the anti-foundationalist champion.
Okay, what was his deal?
Well, he rejected this whole idea that there's a rock bottom of knowledge.
A rock bottom of knowledge.
Yeah, some set of absolutely certain statements that everything else is built on.
Okay.
He thought that was a pipe dream. He was like, science is always provisional.
Okay.
Always subject to revision. We're always building on what came before.
Right.
But there's no, like, ultimate foundation.
Okay. And he had that famous analogy, right?
Yeah, the ship at sea.
The ship at sea. Okay. Tell me about that.
He said science is like sailors repairing their ship while it's still sailing.
Okay.
They got to keep the ship afloat while also making repairs and improvements, but they never get to, like, dry dock it and start from scratch.
So science is always in motion.
Exactly. Yeah. Always evolving, always adapting.
That's a great analogy.
It really captures Neurath's point.
Okay, so while some Vienna Circle members might have had foundationalist tendencies, it wasn't a universal thing.
No, it was more of a spectrum.
Right.
With some folks like Neurath way at the anti-foundationalist end.
Okay, so it's important to not oversimplify their views.
Definitely they were a diverse bunch.
Now let's talk about those pesky theoretical terms.
Ah, yes. The ones that refer to things we can't directly observe.
Right, like electron or black hole.
Exactly.
They seem to cause trouble for empiricism. Right.
Yeah. They raise the question of how can we have knowledge about things we can't directly experience.
Right.
And it gets to the heart of the debate about scientific realism.
Scientific realism. Okay. Break that down for us.
So scientific realism is the view that our best scientific theories, they actually describe the world as it is. Okay. Even the unobservable parts.
Right. So electrons are real. Black holes are real.
According to scientific realists, yes. But there's also anti-realism.
Anti-realism?
Yeah, the view that scientific theories are just tools
Tools?
Yeah, for making predictions.
Mm-hmm.
But they don't necessarily tell us the truth about reality.
Okay, so for anti-realists, electrons and black holes might just be useful fictions?
Yeah, ways of organizing our observations.
But not necessarily things that actually exist.
Right.
Okay, and where did the Vienna Circle stand on this?
Well, it wasn't a simple answer.